Welcome to the myprojectbazaar.com.
This is a project titled Power Cost Reduction in Distributed Data Centers, a two-timescale approach for delay-tolerant workloads. This is a modified title. Design a scalable approach for delay-tolerant workloads to manage the utilization cost in geographically spread DCs. This is the abstract of our process. In a large scale, that is geographically distributed data centers, they have a huge number of servers. Because of the huge number of servers, the power cost is higher. The major problem in the geographically distributed data center is the power cost and delay, because we are going to transmit a number of data to the data center for the processing. So it takes a high execution time because the data size is high. In our system, we provide a solution for this process. We propose an optimization approach for scheduling a job and managing the server in a geographically distributed data centers. Decisions are taken whether the server should be in an active state or not an idle state in a random manner based on the number of arriving jobs. Here we propose a two-timescale approach for delay-tolerant networks. We should not allow the jobs to wait for processing. We should schedule in a short time and we should process the jobs and we should produce results in a less execution time. The decisions are taken to make the server active in a low time scale. Decisions to control the service rates of the server in a faster time scale also. Our proposed approach reduces the power cost and the delay. This is a DFT of our process. In our process, we are first going to identify the data centers. What are the data centers present in our process, and how much capacity the data center can be able to process the jobs? What are the servers present inside the data centers? After that, we are going to identify the arrival of jobs. How much jobs are arrived to the data centers? After that, router schedules the job. The router is nothing but acts like a scheduler to schedule the arrived jobs. After that, backend cluster manipulate the arrived jobs. That is, it schedules and checks the servers present inside whether it is in an active state or an idle state. After that, it's checking the queue space. The queue takes place in each and every server. If the queue is full, means it moves to the next data center's backend cluster. If the queue is not full, means it move on to the next step, that is, it takes the decisions to make the server becomes active or not, depends on the size of the input data. After that, the decisions are made to fix the service rates of the server. After that, we introduce a decreasing time algorithm. Then we are going to fix the priority values, processing the jobs based on the priority values, and perform the calculation of the power utilization, that is the execution of the process. Then we evaluate the power cost. Finally, we show the comparison results by using the graph whether the power cost is reduced by using our proposed approach. Let us see the demo of our process. Open the NetBeans. This is a power cost reduction. In the first run the homepage.java. This is our home page. This is our data center one, number of servers, and it shows the server capacity. Same for the second data center, number of servers. Likewise, we proceed this one for 3 and 4, then for 5, number of servers. Then we continue the process. First, we are going to request the front-end server. So, trigger. Then separately run the client.java. Run. Enter the local host, port number, request, accept the request, receive the request, and here we show the number of jobs we are going to given as the input for the data center for processing. Then store the jobs. Then next. Then show the queue. The queue number of jobs present. After that, this is the selection of data centers, number of jobs present in each and every data center waiting for processing. This is a main queue for the each and every data center. First one, second one, third one, fourth one, fifth one. Next, jobs are successfully stored in queues. Jobs in the queue. These are the data center ID. These are the number of jobs present in each queue. This is a newly arrived job. Here we are going to schedule the newly arrived job to the particular data center. Schedule. To schedule for this job, we should first check the queue space. These two data centers have the space to process this job here. We select the data center and assign the job. Then job is allocated to the data center 2. Now we are going to initialize the server.
Here we are going to perform the server initialization process. Right click the server and run file. Server 1,
Run server 1,
run client1.java,
client1.java,
localhost,
give the localhost, start the job 1, browse, receive, start the job 1, browse the color image, choose,
second
process.
client. Localhost,
Second server, client 2,
conversion process,
localhost, server 3, receive,
client3.java, client
select the Word document,
localhost,
conversion process,
job 3, show the contents in the file,
server 3,
encryption process, show the encrypted contents, client4.java, job4.txt, show the encrypted contents, decryption process, show the decrypted contents. Client5.java, source file, show the contents, counting process. Client7.java, local, client8, localhost, 4, localhost, 10, localhost, let's start the server, client.java, then localhost, okay, receive, then client new1.java, Then next, execution time of all the jobs, power cost calculation, execution graph and power cost graph. Thank you.